Hi everyone, I'm Kristen S. Interia of BS ECE3A and I'm back with another video with my performance task number 6 in my subject ECE23. So today I will discuss on how to determine the transition table, state machine diagram, and trellis diagram based on a given convolutional coder diagram. First, what is a convolutional coding? It is a widely used coding method which is not based on blocks of bits, but rather the output code bits are determined by logic operation on the present bit in a stream and a small number of previous bits. It has also been one of the most widely used error corrections in digital wireless communication. It uses a convolutional code, which is a type of error correcting code that generates parity symbols. So how could we determine a transition table based on a convolutional coder diagram? It is a rate of 1:3, which means that there is a 1 bit input and the 3 bits output. So the input is represented by this arrow, and then the output is represented by N1, N2, and N3. And then the next state will be given by M0 and M1 later on. So how could we determine the value of the output based on the given input and the current state? So if the current state is 0 and M1 is 0 and we input a value of 0, we could determine the value of N1 based on this equation, which is input XOR M0 XOR M1. So 0 XOR M0, which is 0, and M1, which is 0. So we will get the value of 0. Then put this in the table under N1. Then the N2 will be M0 XOR M1. And we will get the value of N2, which is 0. Then N3 will be given by the input XOR M1. Then we will get the value of N3, which is 0, and then put it in the table. Then we will get the value of the next state. Here, if we shifted the input into the value of the current state M0, which is 0, and then the value of M0 will be shifted to the value of the M1, and then the value of the M1 would be cancelled. That's how we could get the next state. So in this, input 0 would be shifted to the M0, and then the value of M0 will be shifted to the M1. Then the new value, which is 0, 0, would be the next state. It would be the same on the others, just like this input 1, which should be shifted to M0, and then M1 would be shifted to M0 would be shifted to M1, and then M1 would be cancelled. So the new value of the next state would be 1 and 0, just like this, and then so on and so forth. Just remember that when determining the next state, the input would be shifted to the value of the current state, which is M0, and then the value of M0 will be shifted to the value of M1, and then M1 would be cancelled. And then next is the state machine diagram or state diagram, which shows the transition from one state to another of the encoder according to the input bit. So first, the value of the current state, this current state we will put it inside the 4 circles in the state machine diagram, just like this. These 4 circles. Sorry. This one. And this one. Then we will put an arrow depending on the next state. Just like in this one, the current state is 0, 0, and then the next state would be 0, 0. So we will put an arrow 0, 0 coming back to the 0, 0, and then labeled it with the 0 input and the 0, 0 output, just like this. This one and this one. Then the next one is 0, 0 to the next state, which is 1, 0. This one, 0, 0 to 1, 0. And then 0, 1 to 0, 0. This one. And then 0, 1 to 1, 0. And then the value of 1, 0 will go to the next state, which is 0, 1. This one. And then 1, 0 going to 1, 1. And then 1, 1 going to 0, 1. And lastly, 1, 1 going back to itself. Like that. And then we will just label it with the input and output relationship based on this transition table. Next is the trellis diagram. So we just put the a 2 column, which is the first column, which is the current state, this one, the first column, and then the second column is for the next state. And then we label the next state based on the value we just copy the value of the current state, and then we just put an arrow just like we have done with this state machine diagram. And also we will label it with the input and output relationship. First is 0, 0 going to 0, 0. This one. And then 0, 0 going to 1, 0. And 0, 1 going to 0, 0. 0, 1 going to 1, 0. 1, 0 going to the next state, which is 0, 1. And then 1, 0 going to 1, 1. And then 1, 1 going to 0, 1. And 1, 1 going back to itself. Just like that. And then label it with its corresponding input and output. Next is the summary. First, a convolutional code is a type of error-correcting code that generates parity symbols. Next, convolutional codes are commonly described using 2 parameters, the code rate and the constraint length. The code rate is k or the input is to n, or the output is expressed as a ratio of the number of bits into the convolutional coder k to the number of channel symbols output by the convolutional encoder n in a given encoder cycle. The constraint length parameter k denotes the length of the convolutional encoder. That would be all. Thank you.